welcome back to another video with the Art of Small. Today we're gonna be doing a video on moons and well what can become Earth's moon. And surprisingly, well, if we go in here and we grab the Earth, put the Earth down here, and then make it so she can't move like that. There you go. The first object we're going to put down is we're going to put down the moon at just what is it, 384,000? 384,000, we'll just put it there. So this is our moon. And what's surprising about the moon is that it's actually, the moon is huge. What I mean by is, I mean, look at the size of this thing. I mean, look at this. Just look at that. Look how big it is. I mean, it's absolutely ginormous. It is, what is it, 3,000 kilometers? No, it's 1,000. Pretty sure it's bigger than that. Anyway, I think it might be Mars that's 3,000 kilometers. But the moon is big. If we look at something like Jupiter, right? Let me look at that. Look, that's stupid. That's really stupid. So what we're going to do is we're going to remove the moon, go to Earth again, and then we're going to put well, first of all, we're going to take the sun, make sure habitable zone is on, get the sun again, and stick it about here. Make it so the sun can't move. And the Earth should start to heat up. And there you go. Alright, so we're going to slow down time again. So we're going to take, we're actually going to take probably one of my favourite objects. Where are you? There you are. We're going to put you at around, we're going to put you at around 1,500 kilometers. Oh, what the hell happened there? Oh my god. Okay, let's alright, so let's take Pluto again. Slow down time. Pluto about this distance. And when we go to Pluto, what we can immediately see is the temperature just starts increasing, and yeah. So Pluto was our moon. It would probably the is it nitrogen on the surface? I think it might be nitrogen on the surface. Right. So if I pause time and then stick. Well, first of all, get rid of this and then stick that there. And then what I'm going to do is I'm going to... Oh! Kerberos. Ooh! 1, 2, 3, 4, 5. 5 moons? Come on, jeez. Alright, get rid of you. Get rid of you. Get rid of you. And get rid of you. And what we can immediately see is basically Sharon doesn't completely get kicked out, but it's on this sort of like elliptical-ish orbit. Well, it is elliptical orbit, but basically right now, Pluto, as the nitrogen evaporates, the atmosphere will slowly get thicker and thicker and thicker until it's like probably just under Earth pressure. So this is actually really good. And we are losing a hell of a lot of... If I just put water on the surface. So basically what will happen is... well, first of all, to make sure that this doesn't carry on evaporating, I'm going to make this 3,000 kilometers in mass. Ooh. A little bit. There you go. So, yes, I've made Pluto bigger, and I know. Woo. Yeah, we lost the water, so if we put that back on. We're gonna... So basically, Pluto would look like... Pluto and Charon. Can't forget Charon. How big is Charon? 600. Maybe make Charon... Maybe give Sharon like a thickish atmosphere. Ooh, no. So basically, it would look something like this. So let's Pluto and Charon. Slow down time again. So let's Charon, let's Pluto, and to be honest, this actually looks pretty cool. Go into the look at that. That's beautiful. And yes, Pluto looks a hell of a lot bigger. And I apologise for that. But over time, as Pluto and Charon come in front of the Earth, there'll be more and more water that will accrete around the Earth and form probably a ring like this. Wait, what's the Earth's axis at? 23.4 degrees. Okay, so if I nope. Tools isn't tools, is it? Okay. make it so it's about like maybe like this. Oh, my bad. Water. 23.4. So basically, it could look something like this. So the Earth could have a ring of icy particles around Pluto. No, around the Earth, sorry. Yeah. Around the Earth. Pluto might have a smaller-ish ring. Like it could... Because Pluto does actually have a ring, and it's actually composed of... I think it's like water. But it's like 100. And if I decrease size of the ring, decrease that again, decrease that, so it could look something like that. So because the Earth, because Pluto's smaller than the Moon, so Pluto, the Moon and the Earth orbit what we call as a barycenter. Basically means that because the Moon is so big, it's huge. It makes the Earth wobble on its orbit around the Sun. It's hard to see, but we do actually. Basically, the Earth orbits the Moon while the Moon orbits the Earth. But the Earth's orbit is incredibly small. It's about like that. No, probably about like that. So it's big, but not big. And basically, because Pluto's smaller, it's about half the radius of the Moon, but it's like something like 16 times the mass. Basically, what this means is the Earth will lose its wobble, and it will barely wobble on its axis. But because Pluto will obviously lose its sorry, I'm just checking this wrong right here. Pluto will lose its moons, but there's a 50-50 chance that all of Pluto's moons may become moons of the Earth. So what we're talking about is talking about something like this. Really? Do they not pop up? No. Next. No? Okay. Next. Brilliant, of course. So basically, if Pluto did develop a ring around itself, it would have to be a pretty tight ring. Now, maybe the outer layers could actually get like pulled away and could become part of the Earth's ring. But surprisingly, Pluto is a very, very light object. Hang on a sec. So yeah, Pluto is actually this big, but I had to make Pluto like, unfortunately, 2,000 kilometers across because it's losing this actually. But this would be interesting, really. So what we're going to do is we're going to get rid of Pluto. Bye, Pluto. Get on Charon. Get rid of the ice ring. Get rid of. Get rid of the ice ring. Get rid of the ice ring. Get rid of the ice ring. Now, the next object we're gonna actually look at is where is it? Io. If Io became a moon of Earth, so if Io orbited about here, it would be hell on Earth. Literally, it would be hell on Earth. The reason why, because for one, Io is the most volcanically active moon in the system. So we could have, if I can find it, Taurus. We could have we could have a ring of sulfur. So if I pause it there. Oh! What did I put that around? That ring. Make that red. Add ring. And make this yellow. Add ring. So we could have something that looks like this. Yeah. I think they've read a little bit too much, but over time, the Earth would accrete a visible radioactive ring of death. Literally. I mean, the Earth would become a cooking. It would become an oven. It would Io would. The chance of the Earth becoming a planet where it literally cooks its life is slim, but it can happen. Now, Io, this thing is just deadly. I mean, because it will be closer to the Earth, and the Earth has more surface gravity, I think, than Jupiter. Even though Jupiter is like massive, I believe it has more, slightly more surface. Basically, the Earth would make a much more of a pull on Io if it was this close, making it a hell of a lot more volcanic active. It would be a beautiful sight at night, but the radiation levels, the Earth's life forms will be okay on the surface. Right now, the greenery is actually it's taking its toll, really. I mean, look at this. I think it lost some of its water, didn't it? Oh. See this. Wait, that's 22. Oh. Sorry, everybody. I didn't mean to cover you up. Oh. What have I done? Is everything in working order now? Everybody alright? Seems like everybody's alright. Oh. That wasn't meant to be there. I have literally just annihilated Asia. You could actually see the blimmin'... God, that's amazing. Oh. America's not doing well. Alright, so let's get back to this. Basically, in order for us to have like space station things around Earth, they would either have to be they should be like really close already, but they would have to be away from this ring. So this ring, it would be a T-Taurus. It would be a Taurus ring. It won't be a flat ring. It would be a Taurus ring, but it'll be highly deadly. So that's Io. Bye, IO. Get rid of that. Okay, so the next object we're going to look at is going to be Titan. Or what about Enceladus? Yeah, we'll look at Enceladus. So we might put Enceladus like closer. Like probably around here. So what's the deal with Enceladus? Well, what do we know about Enceladus? One thing, a couple of things that we know is the Earth and Saturn have basically the same surface gravity. The Earth is the densest rocky planet, and that's a little bit concerning because if Enceladus orbited this close, it will be smothered in cryovolcanoes. Actually, Enceladus will turn into a water world. But it will be a spectacular sight. I mean, it would form, again, it would form a ring around the Earth. Something like that. Somehow it's not working. Hang on, guys. T-toss. Okay. Water. Add. So it would, over time, the Earth would accrete a ring like this. But because these are water particles, the Earth will basically lose its night. So when the sun's light hits the particles over here, the sun's light will bounce off and illuminate. So basically the backside of the Earth would look like a bluish tinge. So Enceladus will carry on like spewing out like this slushy water stuff, and there's a couple good things. One is we could do some research on this. The other is we'll actually have rings for once. But the bad things are, one, we won't have as good tides. Two, our planet will ever so slightly wobble a little bit more. And for three, its days might get shorter. That seems a bit stupid, but the moon stabilizes the Earth. And without the moon, the Earth would just speed up, going faster and faster and faster, until it's like 2 hours a day. So yeah, Enceladus will create a beautiful ring system around Earth. Oh, I've just lost the Earth. Hang on, give me a sec. Let me race off to the Earth. Okay. So then let's get rid of particles. And what we're going to do is we're going to add probably one of the best. We could add. Oh, what's another? Triton. Where's Triton? Where's Triton? Triton isn't here? You gotta be joking me. Triton. Where's Triton? So, again, when we add Triton in, this isn't actually what Triton looks like, really, but I don't think that they've properly animated it yet, or made it surface like what it is. Triton is again similar to Enceladus. It's bigger, but it would be spewing out not as many cryovolcanoes, but basically the Earth may get a bigger but more spacious ring. So something like this. So if I make this bigger, it's a torus water. So it'll look something like this. It'll be humongous. It'll be massive. The reason why the ring will be bigger around the Earth than like Enceladus, for example, is because Triton doesn't spew out water. It spews out nitrogen, methane, ethane, things like that. Basically what it means is that they are lighter, so that they're able to I mean, the Earth would, if they try to carry on resupplying this ring, the Earth will never ever lose this ring. But I mean, I just think that this is, I mean, this just shows that the power of moons in our solar system. I mean, the power is brilliant. I mean, you rings, different worlds, things like that. So next moon we're gonna add is Callisto, and Callisto's a boring moon, really. I really do find it's boring. So if I add Callisto in, everybody says that Callisto's boring, and really it's like our moon. Well, our moon is geologically active. Callisto isn't. That's really odd why it's not geologically active. Because the moon is further away from the Earth than Callisto is to Jupiter. But the moon is geologically active. And it may be because Callisto has a pretty small core, unlike the moon, that now they found out that the moon's core is like, it makes up like 25%. So it's huge. It's like, if I can get a good size. So the moon's core is about as big as Rhea. Actually, no. Well, if you compare the size of the moon, it's about as big as Dino. But Callisto's core is actually really small. It only makes up 10% of the planet itself. But its temperature is actually very feasible. Also for a reason. So Callisto's boring. It would make stronger ties, but other than that, boring really. So let's get rid of that. Let's get back on here. Hang on. Give me a sec. I'll just save this. That. And then I'll reopen it. My systems. I think it's this one. Hopefully it doesn't lag as like last time. Nope. So the next moon we're going to look at is Ganymede, and I think Ganymede is definitely one of the more interesting moons because, for one, Ganymede is practically the only moon that generates a magnetic field. So Ganymede's magnetic field. If we go to Ganymede, Ganymede is really special. It is really, really, really special because for it to generate its own magnetic field, it needs to be a really, like, something needs to be going on inside Ganymede. Something really big needs to be going on inside Ganymede, because Ganymede generates a magnetic field like this. That's a pretty strong magnetic field. But Ganymede is massive. It is huge. I think its core is probably about... I'm not going to change this, but I think it makes up probably 20%. And because Ganymede is bigger than the moon, it can actually massage its own core. And that can generate volcanoes and things like that. It's only like makes up 40% out of 100% of like Earth's gravity, so it's like pretty weak gravity, but still. If we look at some of this, we could see that this may be a volcano. I'm not entirely sure. So that may be a volcano. That may be. So this is practically pockmarked with. So the red means high elevation. The green means normal elevation. The blue means like low elevation. So those might be mountains. It may be a volcano actually. I'm not entirely sure. But all these look like little volcanoes. Probably shield volcanoes. Something like that. Some of these may still be geologically active. And that excites me. That really, really does excite me. So, basically, we could turn this into a sort of like if we can, I don't know, like speed up its rotation somehow. Nope. Speed up its rotation. I apologize. So it's probably at just over 1 day rotation. Then it should be able to generate a bigger core. A bigger magnetic field, I apologize. Probably stronger than Earth's, really. Magnetosphere. Yeah, it is stronger than Earth's. This could actually protect it from solar rays. So in the long run, I mean, if we carry on like just putting water onto Ganymede, like over thousands of years, as the water level drops, we could dump some more on. As the water slowly disappears, like makes a tail behind it. I think we might be able to see. No, we can't see the tail. It could form a pretty thin ring like this. I mean, it'll be an incredibly bright ring, but it'll be a beautiful ring. It would be outstanding to know that our planet has a ring system formed by these water particles that have gotten trapped by the Earth's magnetic field. So basically what happens is, as soon as they leave Ganymede, they swivel around Ganymede's magnetic field for a little bit, and then they get basically pulled away by Earth's bigger magnetic field. They go to the poles, and before some might hit its atmosphere, but some might just follow the magnetic fields and enter like a ring system. And to think about that is outstanding. I think it's amazing, really. So Ganymede is definitely one of the more interesting moons. So delete the rings there. So the next big moon, and oh god, this will be a game changer for us. This will be the biggest game changer in the history of whatever. Basically, yeah. I think, yeah, the moon has a slightly stronger gravitational pull. But oh my god, the atmosphere on something like 98.2, 98.7. I think that this should be amazing. If Titan became our moon, it'll be a marvelous sight. It'll be amazing. It'll be easier because for one, we can go to there, like we can end orbit around Earth and then slingshot towards Titan, end orbit around Titan, probably land a couple of probes, come back and make like a figure eight like we do with the moon. I mean, carry on doing that, and just get research done. I think it'll be amazing. Earth may accrete a rather sparse ring of, if I can make it, of like pretty dull dark, so something like this. So it could accrete a ring like this. And to be honest, that's not a really interesting ring. I mean, it is full of like methane, ethane, like all the stuff. But Titan is geologically active. The reason why we know it's geologically active is because we've discovered volcanoes on Titan. These big like craters on Titan. Titan shouldn't have craters unless they are volcanoes. And we've also detected a huge amount of methane and ethane source coming from these craters. The chance of them being methane volcanoes or ethane volcanoes or hydrogen volcanoes is incredibly high. But I think it will be amazing to see Titan. I mean, Titan may have like a little bit of a tail that goes towards the Earth and makes a ring. I mean, it will only be just barely visible at night, but by day we won't be able to see it. But Titan will definitely, it will be an interesting place. It will heat up pretty fast. But there's no way it will lose its atmosphere because it's geologically active. It's got volcanoes all over it that are pumping hydrogen, methane, ethane, neon gas, all that into its atmosphere. Its atmosphere may change colour, so it may become like a greenish colour. Because it will become more. It may become more geologically active because, for one, it's closer to a more dense object. That's the Earth, and for two, because, well, we humans are destructive and constructive. We're becoming more and more constructive instead of destructive. I think that we could. I don't know. If you think about it, if Titan has a moon, and I think it does, if Titan has a small moon like this, that will be amazing. Like, we can make a base on this moon. I think it'll be absolutely amazing. Because it gives us a chance to study this world. And I think studying this world won't be as bad. I think it'll be a brilliant idea. But hey, delete. Oh no, I've just deleted the Earth. My bad. Let's put the Earth back in around here. So now we're gonna add in probably. Oh, I'm gonna regret doing this. Probably Mars. Good old Mars. If Mars orbited Earth at 10... What is this, 100,000 kilometers or 10,000? At roughly around 100,000 kilometers. One, it would generate massive tides on Earth. Two, the Earth would pull at Mars's surface, making it horrendously geologically active. The Mars is already geologically active, and for it to become more geologically active will be amazing. I mean, it will be a shock. And I'm just looking over Mars right now, seeing all these amazing craters and things. But Mars may become something like this. Climate. Its atmosphere will get thicker. So it could look something like this. So Mars, because there's water locked on its like poles. Oh no! You are not disappearing. Mars could look something like this. I think that would look like a pretty sight. Because Mars, if Mars's Olympus Mons woke up, and what is up with, what is that? That may be a bug or something, I don't know. The aurora borealis will get bigger on Earth. Mars will get its magnetic field back, so it'll look something like this. So it may not be as strong as Earth's, but Mars will have a strong-ish magnetic field. It may be slightly stronger than Earth, really. Probably like 11 just like 0.11% stronger. But Mars will look absolutely fabulous. It would have seasons. Its poles would get bigger. They'll expand, contract, shrink. Sorry, not contract. But it'll be amazing. Like, obviously, this will take thousands of years for Mars to become more geologically active than it is now. And I don't want people putting in the comments saying that Mars is dead. It's not dead, because the probes around Mars have detected numerous magnetic fields, like not just like little magnetic fields, global magnetic fields, like Mars, like having like little bursts of like magnetic fields. But also the rovers on Mars, for the past like year now, they've detected little minor quakes. Like the biggest was about 3.9. That is a big old quake. That's a big quake. I mean, it's not like a 7-pointer, but for Mars, that is a 100% proof that Mars is not dead. Why would you have a 4-pointer or 3.9 quake on a dead world? And I'll say that there's probably going to be somebody that's going to say it's probably water. It may be water. Maybe water running through the surface. But it could be volcanic. Most likely is volcanic. But Mars will become so volcanically active around Earth. Mars will probably glow like a deep red. So that's Mars. I'm not going to put Earth around Earth because that'd be stupid. But if we took something like, what other object can we put around? Europa. I'm going to put Europa slightly closer. And Europa is losing its water. But hey, well, if Europa became a moon, first thing we will notice is, one, it will start to get an atmosphere pretty quickly. Because the increased sunlight will actually start to dissolve the ice, and that will actually generate a pretty thick atmosphere. Like, not just a thick atmosphere, I mean something like Earth kind of thick. And over like probably a couple days, the temperature will drop. Albedo will probably start to drop as the ice melts. The temperature will carry on rising, and as more and more ice is melted, the albedo will carry on to drop. The atmosphere will carry on to get thicker, and when the albedo is about, I don't know, probably about 15, it will still be about minus 60. But when the atmosphere fully turns, and it doesn't want to, about 100 degrees. 100 degrees. Huh. I can't get Europa to have a. Huh. Okay. Radioactive power is stupidly high. 1,000 terawatts. I don't think. Earth doesn't have such a thick. No. But Europa will become water world. Ah, bloody hell. So, next we're going to move on to probably Earth's sister planet. We're going to put Venus at around 100,000 kilometers. And this is when they become a binary planet. I mean, Earth's orbit is bigger. No, Venus's orbit is bigger because Earth is the more dominant planet by far. But they're both just skimming. Well, Venus is just skimming Earth's Roche limit. The first thing we will notice is within days, Venus has dropped by temperature by nearly 50 degrees. This is huge. Atmosphere may drop So if we could just like make the atmosphere drop to probably about 1 atmosphere. So probably just slightly thicker than Earth's. This would be amazing. Oh. I'm gonna let's change it. There you go. So then, because Earth is a lot denser than Venus, Earth will tug at Venus, and Venus is again geologically active. I find it amazing how many geologically active worlds we have in our system. Venus's rotation will start to get faster, and over a couple of months, it would have dropped to probably about 170, 160 days, and that's a huge increase. So basically, what it means is that days and night cycles will get shorter. Venus' atmosphere will be not as thick, and when its temperature stabilizes to about 12-13 degrees, basically what over the next few years, Venus could have a rotation period of about probably 60-70 days. This is a vast improvement. Venus will turn our nights to like a yellowish, dull colour, because Venus will be reflecting so much light. Not as much light as the Sun does, but because Venus is so big, it'll be reflecting a huge amount of light. So then, over the next 10 years, probably 10 years, Venus's rotation will drop to about probably 4.5 days. Probably just over 4.5 days. And then we could think about putting water on Venus's surface. So when Venus has a liquid surface, so if I get rid of this atmosphere, so when Venus looks like this, we don't want to put too much water on Venus's surface. Probably just enough to cover it. But Venus would look absolutely beautiful. This is what Venus may look like. A twin of Earth. It'll be a real twin of Earth by now. Earth similarity will be 98.1%. And life likelihood will be slightly lower, but because of the Earth tugging at Venus's core, Venus will probably have a slightly weaker magnetic field than Earth, but it'll have a magnetic field. Now, because Venus is on its back, it'll rotate in the opposite direction, but that's alright. People who don't mind that will live on here. Venus will also have polar ice caps that will start to form. And it'll actually have a pretty thick atmosphere. It'll have a lot of volcanoes, and those volcanoes will die down over time. And we might actually be able to just calm down the planet, really. I don't know how we're gonna do that, but we're gonna try. I mean, the radioactive power is humongous on Venus. It's probably got a huge amount of metals on it. Because I mean, it ranges like iron, gold, things like that. and it just rains basically all kinds of metal, including like acid. Like even though acid rain is in the metal, it's still its main rain. Then also, yeah, I also got to talk about as Venus loses its atmosphere, it'll cool down, and as it cools down, the acid will get depleted from its atmosphere. So Venus will start to recover. And this band, I don't know what this band is from. I think this is when the object that made the Venus spin backwards smacked into it like poof. But it'll just be one strip of land with a couple of volcanic islands. But Venus will look absolutely beautiful. So that's Venus. Next object is Mercury. We can put Mercury slightly closer. Mercury's an interesting world because Mercury generates its own magnetic field because Mercury has a humongous core and it generates a huge amount of power as well. Atmosphere is actually pretty thin, but over time, if we dumped material onto this planet, we could start to, as Mercury gets a thicker and thicker atmosphere, temperatures won't be as wild. Its rotation speed will drop until it's about probably until it takes about 9 days to rotate. It may get a water ocean. So something that looks like this. And to be honest, I think that this will look absolutely amazing in Earth's sky. It may look a little bit bland with all the grey and blue, but over time, all this will start to turn green over a couple of years, with trees and God knows what growing on it. And as the Earth affects it more and more, how fast does it take to orbit? 2 days. 2.75 days. So basically, it could become tidally locked to the Earth. And to be honest, I don't mind that. But it is like nearly twice as big in radius as the moon. It's 4 times the mass. But it would also create a Barry center where the Earth actually orbits slightly more around Mercury than it does around the moon. So any object that we have just looked at orbits the Earth will have life. Most definitely will have life. So guys, love to hear what you guys like to say. If you like this video, give it a thumbs up. If you didn't like this video, give it a thumbs down. Don't forget to subscribe, like, comment, share. Again, like I said, I would like to hear your comments, like, was there anything I missed? Anything like that. And I will be hopefully uploading a new video tomorrow. Hopefully. So anyway guys, I will see you guys in the next video. Peace out.